In today's digital age, data is constantly on the move. From sending emails to streaming movies, we rely on seamless data transfer. Understanding data travel is crucial for all tech users. Before we dive into the specifics, let's define what we mean by local and global networks. Local networks, often referred to as LANs or local area networks, are confined to a small geographical area, such as a home, office, or school. These networks allow devices within the same vicinity to communicate and share resources. On the other hand, global networks, also known as WANs or wide area networks, cover a much larger geographical area, often spanning cities, countries, or even continents. The Internet itself is a prime example of a WAN, connecting billions of devices worldwide. Understanding this distinction is crucial because it forms the basis of how data traverses the digital landscape, connecting us all. Let's start with LANs, the data highways within our homes and offices. Imagine your home Wi-Fi network. It connects your laptop, smartphone, and smart TV, allowing them to share files, stream content, and more. This is a classic example of a LAN in action. These networks are usually owned and managed by a single entity, like a homeowner or a company. LANs offer high-speed data transfer rates and low latency, meaning data travels quickly with minimal delay. This makes them ideal for tasks requiring real-time communication, such as online gaming or video conferencing. Now, let's zoom out to WANs, the networks that connect LANs across vast distances. Think of the Internet, a massive network of networks. When you send an email to someone in another country, your message doesn't magically teleport. Instead, it embarks on a journey through a series of interconnected networks, each operated by different companies or organizations. WANs utilize various technologies, such as fiber optic cables and satellites, to transmit data across continents. While they might not be as fast as LANs, their ability to connect distant locations makes them the backbone of global communication. Section 5, MAN, the Metropolitan Data Network. Bridging the gap between LANs and WANs, we have MANs, or Metropolitan Area Networks. These networks cover a larger geographical area than LANs, but are still limited to a specific city or metropolitan region. Imagine a university campus with multiple buildings spread across a city. A MAN connects these buildings, allowing students and faculty to access resources and communicate seamlessly. MANs offer a balance between speed and coverage, making them suitable for organizations with geographically dispersed locations within a city. Section 6, the Data's Expedition, a step-by-step guide. Imagine you want to send a photo from your smartphone to your friend's computer. How does that data actually travel across these different networks? First, your phone sends the photo to your home's Wi-Fi router, which acts as a gateway to the outside world. The router then forwards the data to your internet service provider, which connects your home to the internet. From there, the data travels through a series of routers and switches, each making decisions about the most efficient path to your friend's internet service provider. Finally, the data reaches your friend's router, which delivers it to their computer. Section 7, Real-World Data Adventures, from email to online gaming. Let's look at some real-world scenarios to illustrate how data flow impacts our daily lives. When you send an email, the message is broken down into small packets of data, each with its own address label. These packets travel independently across the internet, potentially taking different routes, and are reassembled at the recipient's end. This ensures that even if one path is congested, the message can still be delivered. Similarly, online gaming relies on low-latency data transfer. When you press a button on your controller, the input needs to reach the game server and be reflected on your screen as quickly as possible. Section 8, Understanding Data Flow. The key to smooth networks. Understanding how data flows across networks is crucial for anyone who manages or relies on these networks. By understanding the different types of networks and how they interconnect, network administrators can optimize data transfer rates, troubleshoot issues, and ensure smooth operation. For everyday users, this knowledge helps us make informed decisions about our online activities. For instance, understanding the concept of latency can help us choose the best internet plan for our needs, especially for activities like online gaming or video conferencing. Section 9 Conclusion, Data's Everlasting Journey. Data transfer is the lifeblood of our digital world. From local networks in our homes to global networks connecting continents, data is constantly on the move, shaping how we communicate, work and play. As technology advances, the journey of data will only become more complex and fascinating. By understanding the basics of data transfer, we can better appreciate the intricacies of the digital landscape and navigate it with confidence.